This is a promotional and training video for Sheet Lightning Professional version 6 developed by RevCAD Software, which is a system for designing and unfolding 3D designs in sheet metal. This is me. I'll be showing you around this software today. My name is Trevor Madison. I'm one of the developers here. So let's have a look at the new menu and just see what there is in here. There's a whole list of things that we can access through this menu. One is the parametric libraries, which we'll browse through in a moment. We can create 3D designs using the 3D design environment. So we're creating designs from scratch, or we can load designs and modify them. Then there are loads of special chutes and feeders and various domes, various other things we can load. Again, all of these are parametric design, all except for the 3D design system there. So most of it is easily used just by typing dimensions. These things are split into specials and files here. So and that's the all tab, just includes everything. So let's have a look at the parametric libraries and just see what's in there. If we double click, open up the metric designs, here we have a load of adapters, a load of bends, diverters, junctions, parts that are plane cut, and if any of these are loaded, they will of course come in with their dimensions attached. This is just the simple objects, just for convenience. These are specials, and then there are T's with no offset, T's with offset, normal offset T's, or oblique offset T's. So there's a fairly comprehensive library of parts there, but as I say, all of these have been developed, these parametric designs have been developed in the 3D system, so you can actually extend the parametric designs from the 3D designs just by parameterizing them, and parameterizing those designs, and there are plenty of tools in there to allow you to do that. So let's open up one of these, the diverters. Double click on this design. Here we have an odd leg diverter. Once I've got it in here, I can use the mouse wheel to zoom on it. I can orbit it around using the view manipulators there, or I can just return to the original views here, 2D views really. A useful view for this design. And if we want to, this is highlighted, if we unhighlight it, let's use the select mode. Okay, back to select mode. If we unhighlight it, no parameters appear in the parameter editor. As soon as we begin to click on these and highlight them, up come the parameters, which we can redefine. So let's have a look in 3D. If we want to change this angle here, what this is the beta angle, the angle between these two components, or between the center lines. Now if we want to change that, we can just type in a value, let's say 150 degrees, then weld it up. This is set to manually require the button press. It can be done automatically. And there we see a modified design just by the typing of a dimension. We may want we can get various output from this. We can export solid faces and render it up, get a photorealistic rendering, although we can do that simply from here and get a simple rendering of that object, so that helps us to view it. Or we can export this and get a photorealistic rendering in another CAD system. We can send out the wire frame information that can be used for measuring and that kind of thing. But the main thing we would do with this is unfold it. And here we see the unfolded parts. Again, we're in a view we can zoom on and have a look at the patterns, highlight the patterns, move them around. But these patterns have been placed on a grid of squares. Now those squares are actually printer size, page sizes, printer page sizes, as set up in the file printer setup dialog. And the printer has been selected. If this was printed directly to the printer, it will come out spread over those sheets as you see them there. It could be pieced together like a jigsaw. So that would be one way of manually using the system, but normally you would export the data the patterns to a DXF file, seamlessly it would pass straight through to your CAD system, which would load this data, and you could then use it for CNC and various other things. So that's how the data will be used. Let's close this page. And okay, that's a good view. Let's just perhaps change one more parameter. Let's say the length here. Let's change that to 500. Instantly gets longer. Re-weld it up, and there's that design modified again. So just in this one kind of design from the parametric library, you've got a very powerful tool there for a variety of designs. Okay, let's close that and go back to the new menu, and before we look at 3D design, let's have a look at one or two of the specials. Let's try the feeder. Okay, if we press new, up comes a new special parametric, which is a feeder. Now this can be even more powerful than some of the parametric designs, because it will generate parts according to settings here. So if we go to the pipes setting and set that to 5, what we see is the outlets at the bottom have been multiplied. There's now 5 of them. If I click on one of those, I can, for example, I can open that up now and give a down rotation of say 45 degrees. And there we have, let's have a look at the solid view of that. Just with a couple of parameters we've defined that. Let's go back here and let's say change the length to say 300 millimeters. Zoom it into view. Let's just have a look at it. And there we have design. Let's orbit it from here. Parametric design that can be unfolded. Again, and there are the patterns, and either printed or exported to the CAD system to be used. So that's an example of using the parametric specials. Let's close that. The parametrics are great, but they do constrain the design scope. So if we want to break out of that kind of restriction, the thing to do is to use the 3D system. So here what I'll do is browse some of the 3D designs we have here. These are not parameterized. These have been created simply in the 3D and kept in the 3D. So let's try loading a similar design, which again is another 2-leg diverter. If we look at this from various angles, we can see. Let's just cancel that and unfold that. Weld that up. So we've just welded that design. Let's go back to the 3D view. Now, once I've got a design like this in here, the way to modify it is using these tools rather than parameters, as there are no parameters attached to this. We could actually parameterize it, but the trouble is when designs get complicated, the number of dimensions needed to give it reasonable flexibility just escalates, and it becomes untenable to alter designs that way, and it's better really to use the 3D design system after that. Now to give an example of that, if we press the normal activate, this will give me various node options I can select, and if I select one of those free end nodes, I can start to move a part. This is an axis snap. I'm going to snap to the axis here, and that will align me to the axis. I can align myself to various angles and things. I can use the other objects to align myself. But in this case, I'll just align myself to an axis. I can uncheck the length there and just stretch the length out. Or I can type in a new length, 500 let's say. That will fix the length. Then when I drop it, it will say, okay, do you want to match this? Well, I do want to match it, because to get a valid intersection here, this end size of this needs to be matched in. So I'm going to use taper matching, and I'll match that, and now the proof of that when I weld it is that it all fits. So that's an example of loading a design and modifying it. Quite easy to do. We can also do things like duplicate a part, so they have taken a copy of that, and maybe I want to link that back in to here, and this will actually weld up without matching because it's already matched from this other, it's identical to this other part here. So there I've just created a design modification, a kind of two-leg diverter with an extra take on it where we might want to inject something, some fluid or something, or some air. Okay, so there we have a good example of using the 3D design system. Also, the beauty of this is we may let's go to select mode here. We may want to combine designs, so if we say open something from the parametric library, let's say this diverter here, we can convert that to a 3D design. So it strips off the parameters and converts it to a 3D design window. We can then highlight and copy, or just copy all. Let's copy the selected there, and if we cascade these windows and go to the other window, there's still the parameterized one, which we can delete now. If we go to this window, we can go edit, paste, and pick a node and take in that design into here and begin to combine it. So I can hook this on if I wanted to. Let's do that. Let's zoom on this, move it, and why not just hook this onto the end there with a node snap. Of course that's not matched, so we need to match something here. If I say now match selected, and I'll say yes, I want to match to that part and that part, match it, and now weld it. We've actually combined two designs from separate places, and the power of that is immense in terms of creating something customized. And there are all sorts of tools here for rotating and dragging and dropping and stripping it apart and linking it back together, and all those things are fairly easy to do. In fact, it probably would be worthwhile just to cancel that and have or start a new 3D design, just show you how simple that is. It's just a case of using the create part and putting points in there, and then this comes up with sections that we can change here, various sections, or we can just modify this parameter to say 400 millimeters, and in goes a part. Then if we want to create another, we need to link onto that to get an intersection, so either node link or centerline link. So if we, here the cursor is restricted to the center line, and I can find a position along there by typing parameters, but I'll just click and pull off a new part. Let's have a look at it in 2D. Here I can say do an angle snap of 60 degrees to that, and say yes to that. So there's that fixed at 60 degrees. I could set that to a length of, let's say, 1000 millimeters, and there we fix that at 1000 millimeters. I won't bother sizing this because I'm going to match it, so I'm going to say okay, I want to grow match this to the design it's linked to, match, and there it is. And if we weld, there we see I've created a simple T using only the 3D tools, which was really quite easy to do. We also have the possibility of oblique. Let's load an oblique design. So if we open the 3D CAD design, rather than open, it comes up with the file open. Let's do the browse. Open, browse, 3D CAD designs, and here we have an example of oblique cones. And let's just weld this up first, just to show you how it fits together. So there's a fairly complex design. Now if I wanted to unlink this, I could press unlink. Do I want to unlink and drag it? Yes, I do. I'm going to drag that away, and now I'm going to modify this with the oblique movement. Okay, let's cancel that. That is rigidly located there because it's on a construction line, so it's rigidly located at both ends. Now I could just delete that construction line, but what I'll do is I'll unhighlight that. Let's unhighlight that, just highlight that one and strip that off too. So I'm going to unlink it and drag it and then work on it. So you'll find a bit of space here, and now I want to modify this with the oblique offset. Now normally I would use construction lines to find a position for this, but I can just find a location, press that, put it down. Let's hook this back onto the end. So move this and hook it onto the end here, and then we're going to move this. Because that part is linked to it, it will drag with it, and then I'm going to link on to this node back here. And if I weld all, I've modified that design by changing this oblique, or I could copy that and create another oblique offset. So even there is a very powerful facility for creating cones with oblique offsets. There we have another good example of using the 3D. Now, just as another example of kind of powerful design features we have here, let's go and have a look at the spiral chute. There are a number of different chutes in here. Some of these come with the standard version, some just the professional version. So it's actually worth the extra cost of the professional version. It doesn't cost much more. In fact, this is a very low cost system. The reason for that, don't let that fool you, it is a very productive system used around the world in many countries, and is at the basis of business for many people. It's their best kept trade secret. As you can see, the very powerful design capability at very low cost. Our idea is that every man in his workshop should be able to afford it. So we try to keep the costs low and sell it on a volume basis, just to get it out there and used. So we ask you to respect the licensing costs. If you're using multi-user, buy a multi-user license. It only costs 2.5 times a single user license. Just respect it, especially since the liability of misusing sheet lightning is actually every bit of profit you make from it. So it's just not worth going down that road. It's best to just get licensed properly, and it helps us to continue to develop and come up with better things, and there are better and greater things going to come with this system as time goes on. So let's have a look at this as a very powerful feature, which is a spiral chute. Let's click on here and say give me 18 segments rather than 11. Just give it time to regenerate, and there we have 18 segments. Let's change the turn angle to say 360 degrees. And here we have start radius, end radius, and we have the overall height, all of which can be changed parametrically simply. And then when we're ready, as before, we can unfold all, and off it goes. It will work out the patterns for the whole of that design, and as before, put them into an unfolded window. There we go. So this is quick and very easy and very powerful in terms of what you can design using that. And of course you can, as we showed you before, convert that into a 3D design, continue to work with it, or strip it down and just use parts of it. So the parametrics and the specials become a basis for starting a new designs. So it can be very powerful. Finally, just to kind of blow your socks off in terms of what is possible, let's exit that and show you something else, which is the DXF import. And here we are able to import designs. Let's take, for example, this spiral. Now this is simply a line design, nothing more. We have spokes, we have a spiral around it. So there are various parts to this. That's the middle piece. If we say OK, that will be imported into here, and that was all created from a line drawing created in another CAD system and dumped out in DXF. So we can weld all that, and there that design was completely welded up and can be unfolded. So that can be very powerful means of design. If you're familiar with another CAD system, let's close that and open something even more probably elaborate than that, which is the Eiffel Tower. There, rather than do the whole lot, let's just concentrate on the lower section. These are put in separate layers. It's 200 millimeters diameter. Let's increase that to 2 meters diameter, because this tower is actually Eiffel Tower size. Can of course scale it down, but there you see all the parts, and I could simply import that and deal with that, handle that in exactly the same way as you've seen all the rest. Won't do that now because it'll take quite a while to process that, but all these intersections will be handled by sheet lightning, so there really is no limit to the design possibilities here. And DXF importing, which is professional version only, but it is a very powerful feature, and makes an awful lot of things possible if you're familiar with a different CAD system. Finally, let's just show one or two of the more unusual or special design features, like domes. You can create domes. Now this is not always sheet metal, it can be for lampshades or things of that nature. So there we have all dimensions to alter that. If we want to go to 14 segments, there we go, and it will split these up into strips that you can just print off in the same kind of way or dump out in DXF. What else do we have here? Of course we have swept designs. Here we have a helix chute, which is kind of a flat base chute with sides to it, and 1.5 coils there. Let's change that to 2.5, and again this will unfold into flat strips that can be fabricated or cut up into smaller parts. So there are some other different special items in there, all of which give it design scope, incredible design scope, and I'm sure you'll appreciate well worth the money. Let's have a look at that in solid. You can get a solid view of that, and on it goes. So thanks for watching. The videos that follow are mainly for training to get you actually into the detail of how to use this, but this has been a good overview just to give some idea of its capability.